Hello everyone, let's talk about factoring the difference of squares. To factor a squared minus b squared, we use this formula, the quantity of a plus b times the quantity of a minus b. We can easily verify this formula is true by foiling the right hand side. Now, let's get started on how to use the formula to factor the difference of squares. Okay, so the first example is a simple example here, x squared minus 9. So what we do is that first we are going to write it as a square minus another square. And so we just need to figure out the a and then the b according to this formula. Okay, so now what happened is that we need to figure out the first blank. The first blank is the a, and then something squared gives us x squared, so that would be simple. We will just have the x as the a. Okay, and then now what is the b? The b is something square, okay, and that gives us the 9, so we just need to write down the 3 here because 3 squared is equal to 9, so b is equal to 3, okay? So now all we need to do is to write down what a is, what b is, and then we have a plus b, a minus b as our factorization. So we are going to get something, and then something plus something, and then something minus something, and then those are a plus b, a minus b, so we have x for the first spot, and then what about the b? The b as the second spot for both binomials. And then we have the factorization. So x plus 3, x minus 3, we will get the answer. Let's look at the next example. Okay, second example, it's almost just like the first one, except that the number is different this time, but it's the same thing, right? So we are going to simply just rewrite it as something square minus something square, and then we just need to fill in those blanks. And once we fill in those blanks, we have the a and b, and then we can write down the factorization. So as you can see here, just like the previous example, then we are going to just get x here because x squared is x squared, and then something squared gives us a 25, so we are going to be getting a 5 here because 5 squared is 25. So now that x is a and then 5 is b, and then we can now write down the factorization. So we have the two binomials, one of them with the plus sign in the middle, the other one with the minus in the middle, and then we are going to get a, which is the x, and then for the second spot we need to put down the b, so we get 5 here and then 5 here, so we have the factorization. Okay, so that's even faster than the previous example. Now we are going to look at more difficult examples. This third example here, we just make it slightly more difficult because we have a coefficient other than 1 in front of the x squared, but it actually makes no difference on how we are doing the problem. We are still going to start the problem by writing blank square minus blank square. Okay, so we need to figure out what a is, what b is. Now let's ask ourselves, what square will give us 9x squared? So something square must give us a 9, and that something must be 3, but that's not finished yet because that will only give us the 9, right? So we need the x here, so x squared will give us the x squared, so we just get x. So a is 3x, and then now we just need to figure out the b, and something square will give us 16, so we gotta put the 4 here because 4 squared gives us the 16. So now we figure the a and figure the b, and then we can now write down the answer as, again, we have the two binomials here, one with a plus sign in the middle, the other one with a minus sign in the middle. So now we have the first spot is a, so 3x, and then also 3x here. And then what about the b? The b would just be the 4, so we get 4. And then 4 here. So now our final answer is 3x plus 4 times the quantity of 3x minus 4. So now we are done. And let's look at the next example. Okay, let's keep going. So now let's look at this example here. We have another one, and that's not really different from the ones that we were doing before. The difference is that now we have a constant in the front, and then we have the x squared is the second term, right? And then you can see that the coefficient of the x squared is a negative number. And so now how does that affect our answer? You will see. So, but we are still going to just use the same idea to factor this. The way to do it, again, just like the previous 3 examples, we are going to just write square minus another square, and then we just figure out the a and the b. And so now the a is actually easy to figure out because something square gives us 25, and that something must be 5, right? 5 squared is 25. And then now for the b, okay, for the b, what we do is that we need to figure something square, and then we will get 4x squared. It's not okay to put a 4 here. Just remember that's a common error that I see. It's that when you square the 4, you will get 16. So you will actually need to put a 2 here so that the 2 squared will give you the 4. Is that okay? And then now something squared gives you the x squared, so that would be easy. So we just get the x here. So now a and b I figure out. And then the rest is really just writing down the answer based on the formula here. So a plus b, a minus b. So we have a plus b, and then a minus b. And then what is a? A is 5. So we put 5 for the first spot for both binomials. And then what about the b? The b would be 2x, and then the 2x here. And so that's it. So it's not really that different from the previous problems, except that now the x is in the second term. And then of course, if you switch them, then you can still get the 2x plus 5 for the first factor. But for the second factor, if you switch them, then you also need to make sure that you bring the negative sign to the front, which will give you negative 2x plus 5, right? So this one, you can also think of it as negative 2x plus 5, but usually we don't do it that way. Okay, so that will be our final answer. And then now let's look at one more that's slightly more difficult than one that we have seen, and that one is more interesting. Okay, so let's get to that one. Okay, here's the last example. Then you may say, hey, I thought we are talking about the difference of two squares, right? Why do we suddenly get a fourth power here? Actually, we can treat the fourth power as a square, right? So we are still going to start the problem the same way. So let's actually write it as something square minus something square. So just like before. And then we figure the a and the b. And so now what is the a? So something square gives us x to the 4. So we can actually write x squared here because you square the square, you're going to get the fourth power. So you get the a. Okay, so that's easy. And then now what about the b? The b is actually the easy one because the b is actually just you square something, you get 16. And that's a number, right? So that would just be a 4 here. And so right now we can actually write down the answer. So the answer would just be something plus something and then something minus something, right? Just like before. Okay, so we get x squared and then x squared here. And then so we have 4 here and 4 here. And then you may say, are we done, right? It looks like we're finished, right? But because you still have the difference of two squares right here, we have x squared minus 4. And then, so what happens? We actually need to just continue to factor this one. Okay, so let's factor. This is again, it's the difference of two squares. So we are going to just write it as x plus 2 and then x minus 2. That is according to this formula. We just do it one more time. And then you may say, what about the x squared plus 4? That's the sum of two squares. And so we are not going to be able to factor that one. So we are just going to leave it. Well, we can still factor it over the complex, but then we're not able to factor it over the set of integers. So we are going to leave it as it is right now. Okay, so that is the final answer. Okay, so we will do more difference of two squares. There are more variations. There are more difficult examples. We'll do more of those next time. And this video is really just for showing you the basics and then showing you a more interesting example, because sometimes we just get it done and then it feels like we can stop there. But then in order for us to factor it completely, we actually want to just factor, just keep paying attention to certain factors that can be further factored into smaller factors. Okay, so now that's the final answer. Okay, so thank you for watching this video. I will see you guys next time.